Okay, I gave you another 3 add-on lessons, mostly for those kids that are taking that AP exam. We have not done a definition for finding the average value for integrals, and it talks about it here. The one thing I want you to pay close attention to is this right here. This is the formula when they want you to find the average value. It is really easy to miss that whenever you're reading an AP problem, because the word average just doesn't stick out. It's not like a big math word. It's one of those words that we use, in everyday talking, so that when we are reading these problems and we see average value, we don't think to use this formula. But this is the formula that you're going to have for average value, and basically it's like, what's the average Y value? And then you could find the C where it occurs, but this f of C is actually the average value, okay? So having you know that kind of helps. That makes sense that this would then be equivalent to f of C, right? And so if you looked at this formula up here, you would see that if you divided by b minus a on both sides, you would get that f of c is equal to the integral divided by b minus a, which is the same thing as 1 over b minus a times the integral. So again, those two are very connected. They make sense. Sometimes people think of it like that, and which is the same thing we just talked about. But so average y value, which they're saying is could also be thought of as average height. So example number 1, find the average value of f on the interval from 1 to 4. And so again, once you read that average value, that is, that's your hint that you're going to use your 1 over b minus a times the integral from 1 to 4 of 3x squared minus 2x dx. And so this would be 1/3. And then if I integrate, I should get x cubed minus x squared from 1 to 4. So 1/3, and then this would be 4 cubed minus 4 squared minus 1 cubed minus 1 squared. So 1/3 times 64 minus 16. Of course, that'd just be minus 0, so I'm not going to worry about that. 1/3 times 48. 48 divided by 3 is 16. So what they're saying is that the average y value of this function between 1 and 4 is 16. And so now in part B, it says find the values of c guaranteed by the mean value theorem for integrals. So, if you wanted to know the c where this occurred, then you would set, since that 16 is your f of c, right, you're going to set 16 equal to, and then I would just put a c in here. You don't have to, but just so it kind of makes sense, that this right here was your f of c, so that, oh, that must be equal to this when my x is c. And for this one, is it factorable? If I put a 2 here, that would give me 6, and an 8 here. And if I made my 8 negative and my 2 positive, that would give me my negative 2c on the inside. So that means that if I set these equal to 0, and then you have to check, okay, you're talking about this interval from 1 to 4. And you're thinking, which one of these is actually in my interval? And you're going to throw out the one that isn't, okay? So this 8/3 is going to be your answer. So c equals 8/3 is where f of x achieves its average value of 16. And you could say on 1, 4, because of course it was specifically on that interval, okay? All right, example number 2. In 2000, the world's population was 6.1 billion, and the relative rate of growth was 1.4% per year. This can be modeled by the function n of t equals 6.1 times e to the 0.014t, where n is people in billions and t is the number of years since 2000. Assuming this model remains true until 2050, find the average population of the world between the years 2010 and 2020. So we're going to find that average population, and if it says t is the number of years since 2000, this would be from 10 to 20 for us for the t value. So this would be 1 over 20 minus 10, integral from 10 to 20, 6.1 e to the 0.014t dt. Okay, that's going to be your formula for finding that average population. So we've got 1/10, and if I integrate, I know that my 6.1 is going to stay because it's being multiplied, but when I use the chain rule, I'm going to divide by the derivative here, which is 0.014. And so you end up with, I don't know, I went like that with the 1/10. So I basically divided that by 10. You could have, done it differently. You could have moved this over on the bottom. But then I went ahead and put my e to the, and when I put 20 in, I got 0.28 minus e to the, when I put 10 in, I got 0.14. And then I used my calculator and got approximately 7.532, and this would be billion people. Okay, so that's just using it for a word problem, and I like to, on word problems, go back and just kind of rewrite to make sure that I am, answering the question. So I would have said the average population of the world between 2010 and 2020 is approximately 7.532 billion people. So again, that's just kind of, you got a word problem, you end it with a word, with words. It's a good habit to get into for word problems to get ready for that AP exam. All right, example number 3. Suppose C of t represents the daily cost for air conditioning your home in dollars per day, where t is the time in days and t equals 0 corresponds to July 1st, 2017. Explain what the following expressions represent in real-world terms, including the units. So daily cost for air conditioning your house in dollars per day, and t is time in days. So you're talking about 90 days here for part A. And if I'm integrating C of t, that's going to be my total cost to air condition my house for those 90 days. And so since it's starting July 1st, 2017, this would be for July, August, and September of 2017. So let's say total cost to air condition. And remember what I said. Dollars per day was my C of T, right? So if I integrate, I'm going to have dollars, right? So when you integrate, you always have, when you integrate a rate, you know, so dollars per day is a rate. You're always going to end up with the numerator of your rate as what your answer to your integration is. So this answer is going to be in dollars. So total cost to air condition your home for the months of July, August, and September 2017. All right, and then look at the letter B. Now you can see this is going to be the average for those 90 days. So this is going to be oh, you know what, I forgot to write in here, in dollars, sorry. Okay, this one's going to be the average cost for a person to air condition their home in dollars per day for 90 days from July 1st, 2017. Okay, so example number 4, Supersonic Man. On October 14th, 1947, Chuck Yeager flew his X-1 rocket plane at an altitude of 12.8 kilometers. He was clocked at 299.5 meters per second, which is about 669.962 miles per hour. At different altitudes, sound travels at different speeds. We can model this variation for speed of sound with a piecewise defined function given below. And so, part A, integrate the function s of t over the interval from 0 to 80 for the 5 sub-intervals. Okay. And so for this one, we're just going to, for part A, for part A, they just want us to, like if we were integrating this from 0 to 80, they want us to basically, you know, take it and put it into pieces. So, you know, from the first piece of it is from 0 to 11.5, and that piece is negative 4t plus 341 dt. And so this is going to be negative 2t squared plus 341t, from 0 to 11.5, and that's going to equal, if I put that, negative 2 times 11.5 squared plus 341 times 11.5, I put that in my calculator, I would get 3657. And then they want us to integrate from 11.5 to 22, right? Because to integrate this function s of t, you have to integrate it in pieces because it's a piecewise function. So you're integrating, you know, it's like you're taking it in little pieces. So that's what we have going on here. So this one's going to be 295t from 11.5 to 22. So 295 times 22 minus 295 times 11.5. put that in your calculator. 3097.5. Now this piece of it, from 22 to 32, 0.75t plus 278.5 dt. Don't forget your dt. So this is going to give us 0.75 divided by 2 t squared plus 278.5 t from 22 to 32. So this gives us 0.75 divided by 2, 32 squared plus 278.5 times 32. I'm going to put that whole thing in parentheses, minus, I'm going to go like this, minus, parenthesis, 0.75 divided by 2 times 22 squared plus 278.5 times 22. And if you put that in your calculator, you should get 2987.5. And then we do the next piece of it is from 32 to 50. And for that one, we have 1.5t plus 254.5 dt. So when we integrate, 1.5 divided by 2t squared plus 254.5t from 32 to 50. 1.5 divided by 2 times 50 squared plus 254.5 times 50 minus 1.5 divided by 2, 32 times 32 squared plus, oh my gosh, 254.5 times 32, and put that one in your calculator, and you should get 5688. And then that very last piece from 50 to 80, negative 1.5t plus 404.50 dt. So this one's going to be negative 1.5 divided by 2 t squared plus 404.50 t from 50 to 80. So negative 1.5 divided by 2 times 80 squared plus 404.50 times 80 minus negative 1.5 divided by 2 times, 50 squared, sorry, accidentally put 30. Plus 404.50 times 30. And if you put that in your calculator, you should get 9210. So that is how you integrate that whole thing, all 5 subintervals. And so if I integrated here, if I said, okay, my integral from 0 to 80 of my s of t dt, it's going to be the sum of all of those numbers. So 3657 plus 3097.5 plus 2987.5 plus 5688 plus 9210. So, you know, if you want to add those up in, but that's going to be your actual, but I think it was enough to just show that, you know, but just so that you guys know that if you were doing a problem and they were actually wanting that last value. And then for part B, apply the mean value theorem for integrals to find the average speed of sound. So for that one, Your average speed of sound is going to be 1 over 80 minus 0, integral from 0 to 80, s of t dt. So that's going to be your 1/80th times, and it would be all these added up. And if you did add them up there, my 5s keep messing up. You know, you could just put that number in. But when I get done and I add those up and divide by 80, I get 308. And think about what that's going to be, because here they told us that this was meters per second. Over kilometer, or meters per second per kilometer. But when we integrate, we're just left with meters per second, right? We're just left with that unit there. So this is going to be 308 meters per second, but the speed of sound, we typically measure the speed of sound in miles per hour. So we're going to go ahead and convert this to miles per hour. So to do that, we're going to go from meters. I like to go, if I'm trying to go to miles, from meters to miles, I go to centimeters, because I know 2.54 centimeters is 1 inch. And then I go from, 12 inches to 1 foot, and then I can easily go to miles then. 5,280 feet is a mile. So now I'm in miles per second, and we want miles per hour, so we want to get rid of seconds. And we could say that 3,600 seconds is 1 hour. Or you could have done seconds to minutes, minutes to hours. And so now your meters cancel, your centimeters cancel, your inches cancel, your feet cancel, your seconds cancel, and you're left with miles per hour. So 308 times 100 times 3,600 divided by 2.54 times 12 times 5,280 miles per hour. Put that in your calculator. You should get 688.976 miles per hour, speed of sound. And then for part C, draw the average value S of C on the graph below. So that's going to be in meters per second, that 308. So what they wanted us to do there, I'm just going to erase this little line. What they wanted us to do there is just draw that in there. It's about right there. And that's your Y equals 308. Yeah. Meters per second. Okay, so you can see that that's like the average. So that's a good way to check yourself. Make sure your math's right.